Hello everyone, my name is Abhishek Chen and welcome back to the tutorial series where we are trying to build our own automation framework to test a RESTful web server, right? So we have already seen we have a very simple web server which has 4 API endpoints. I just recently added a matrix to my own web server and I used the FastAPI module to just build that, right? So you can ignore this matrix for now because I'm just trying to implement the Prometheus, so that we can just, track or monitor, our web server. But what we have done so far, we have automated, our get, post, put, and delete, where we are having create users, one of the API endpoint which actually creates the user. Then we have get request where we can extract the user information. Then we have a put through which we can update the user information, and through delete we can just delete that. So we have already automated that part. So if you haven't watched those videos, so there are three part which already there on YouTube, and you can just see the link for all those three on your screen on a top right left. Right. In today's video, what we're gonna do is we're gonna write our test which gonna help us to figure out the performance or our performance of our web server. That's one thing for all the various endpoints. And we're gonna see how we can leverage those performance tests, with little bit of tweaking to perform a load testing, stress testing, and the soak testing for our web server. So without further delay, let's get into the demo part because that's the always interesting part for us to do. So I'm just gonna create a Python package and I'm gonna call this Python performance, test performance basically. Let's see. Now, the next question comes into the mind, whether we are going to use any existing tool or the framework. Yes, we're going to use a Locust, which is an open source library through which we're going to build our performance test for our RESTful web server. There are many other options, like if you want to use JMeter, LoadRunner, or the Gatling, you can use them as well. But Locust is very easy and it provides us flexibility to write our code in a Python. That's the reason I have a little bit of inclination towards using a Locust, and it's very, very easy to use, right? So as always, as I mentioned, it's a Locust library which we're gonna use. So here is, you can, if you just search for the Locust on Google, I would say just search for the Locust PYPI and you will get this documentation, and I can provide the link into the description. So it's very straightforward. All we need is we just need to install the dependency, which is for Locust. So I'm just using this Locust and it's already been installed on my machine. That's the reason we are getting this. Now, the very first thing which we have to do for writing any test, we have to, for Locust, there is a requirement to just use this name Locust file, right? So this is just a requirement and it's not mandatory to always have this, but if you have your test written in Locust file, and if in the same location, if you just run the Locust command, because once you install this library, then Locust command is something which you can just hit on your command line and it is going to just give you the web UI through which you can control your test. And we're gonna see all these things in, in rest of the videos, right? So first write this and then we can just talk about all those things. Otherwise, I mean, if I'm not able to cover in this video, probably I will just come up with some more videos. And if you are really interested to understand each and everything of Locust file, there is a lot of tutorial available on YouTube which you can refer. And if you want, I will just provide some link which I felt that it's very, very interesting and easy to understand with those tutorial series, right? So the very first thing which we're gonna do is from Locust, we're gonna import bunch of classes like HTTP user, task, and theme, and then we have to just create our own class, and we can say RESTful app user, and we have to inherit this HTTP user class, and then we have to just build our own method. So let's say if we want to just do the performance for get user, so you can just write your method. The name of the method is not interested. The main thing which is interesting here is you have to use this task, which is actually going to tell Locust, okay, this is the function which you need to execute, right? So task decorator is nothing but which actually tells the Locust, okay, this is the function which you need to execute, right? So what I'm going to do here is So we're gonna use self, you know, and in the self, we have this client, which you can see. This is just a method of the function which actually Locust has created for us. And the very first thing which you have to do here is you have to feed in your endpoint detail, right? So we know that the endpoint detail is users. If you want, you can just, go here and see in get. We know that this is my get endpoint looks like to extract the information for user. And if you have watched, my previous video, you would be knowing by now that this is the endpoint which we have to hit, right? That's one thing. And then we have to just give is a name. Name means if you want to give a very meaningful name, like because this is the name you're gonna see on your Locust web UI, which we're gonna see in just a couple of minutes. Okay. And then I'm gonna say time sleep for 2 seconds, and we don't have time, so let's import time module. Okay, so this looks good. Now we need to feed in the user ID. Oh, task here. Okay, so this looks good. And I can give a user ID, for example, now with one specific user ID. Let's check DB. Okay, open in terminal. US. Okay, so we can use any value. Let's pick first one. Okay, and then it's this one for now. Okay, and this looks good, I guess. But if I haven't made a mistake, I should be able to run this. So let's see what happens when I just hit. See, this is the advantage. Could not find locust file.py. Oh, I'm not in the location where we have this locust file. So that's the reason it complains. Okay, so by default, it is able to find that locust. And once this, you hit this command, just see, you have to just write only these line of code, and you are good to run your performance test, your stress, your load, and the soak testing, and that's what we're gonna see. So this is the URL which you need to use. So let me just come here and get this. Okay. Oh, I made a mistake. I just cancel this. Let's run one more time. Let's refresh it. Okay, so we have now see we got this web UI and we haven't done anything. All we did is just install our Locust module and we have this, right? And then we just wrote bunch of line, and you can just read through the documentation. Documentation is very straightforward. If you just follow through, you can see, I mean, this is how it has to be written, right? So what it says, the very first variable, number of user, how many users you want, and then ramp up user. Ramp up user means, let's assume that you want to run this test with 10 users, right? And ramp up means it's actually the rate of the user which you want to add, because it's going to start with the one user and it's going to increase the number of user based on this value. So if it is one, then one user at a time is going to be added. If it is two, then the two user is going to be added, and that we can see, right? And this is where our our web server is running currently on 8000 port. And if I run this start, let's see what happens. It's going to take a few seconds, but here if you just see, notice user, it's 8 and it's 10 now, right? And we can see this here also in chart. If you just see number of users, it start here and it's keep increasing by two users, and eventually it just get consistent at the 10 users, right? Let's see what is happening here. Okay, so it's failing. Why it is failing? Let's fix this. Type error where I just make a mistake, but where actually I made a mistake. Oh, I forgot to hide this. Hmm. Okay, now we should be good. Okay, let's start one more time. Let's keep a track here. See, ramping of 10 user at the rate of 2 user per second. So every second you're gonna add 2, it's gonna start from the 0 and it's, keep adding 2 users, after every second, right? And if I come back here on Locust, we can now see the 10 users are there. And we can see now how many requests has just went through the system, 88 requests, right? So here you can see, some statistics which are very important. Like, I mean, this is where, this name variable which we have in our methods comes into the picture. This user, you can give any name, whatever you want, and that is actually going to be reflected in the Locust value. Then we have a number of requests which has sent so far. Here you can see the RPS, which is request per second. And then you just see the responses, 95% of, request, what's the average time in milliseconds. You can just keep seeing all these numbers, and whatever the non-functional requirement you have from your web server, accordingly you can change that, right? So for example, if I just stop this and if I just want to, let's assume, increase this to 20 users, and I want to ramp up by 5 users, let's start this. Here, just keep see on a user section here on the top banner in a green color, user is 20 now. See the requests are keep getting here, and okay, so for 20 users, right? So likewise, if you want to increase more number of users, you can do that, right? Similarly, what I have done is to just save time for ourselves, and what I have done is I have just what I'm going to do, I'm going to replace this entire thing from all the tests which I have written, and I have this utility. Utility is nothing but which we have written in the previous part where we are actually generating the test data. So what I'm going to do, I'm just going to copy this and I'm just going to paste it here. Okay, so this looks good and we should be good now. Cool. So here you can see I have this weight, but you don't have to worry about for now. All you need to understand what this weight actually does. This actually sets up the probability. So now if you just see in this same class, we have 4 different methods, and each method is actually pointing to the specific endpoints, right? So by having weight with the higher number means the probability of executing this method is higher, because what Locust does is it finds how many tasks we have and it's randomly start executing them, right? But if you provide a weight, then whatever the value you assign, that value is being used by the Locust to decide how frequently that given method has to be executed. So if you just see for the get user, I have weight 3, and the maximum weight I have given for the create user, it means that what I want is the create user has to be executed more frequently as compared to the get user. And same with update user is 2 and delete user is 1. So this is just a very real-time approach, because we know it's very rarely we need to delete the user, it's very rarely we have to update, but creating a user and getting the user information is something which we have to do very frequently, right? So that's the reason I have just put that on a higher weight, right? So let's see what happens if we run this test now. Okay, everything looks good. Let me just run with not, but let's see with 5 and just give 1 here. 4. So we can see user 0, 1, 2, and let's see. And don't worry about the code which I have written. I will be pushing that to my GitLab repository, and I will be giving you the link in GitLab. So here you can find all the code which we have written so far for all the parts. Okay, so there is some issue where this put data is not having attributes, and I know why this is happening, because as I mentioned that Locust actually execute these function randomly, right? So if let's assume you have a one round of execution and another round of execution, due to some reason, if Locust choose this update user, right? And if you see this update user is actually using this self put underscore data, and where we are setting this up, we are setting this up here, right? So if in any execution cycle, if update user get executed before create user where these variables are not set, and we're gonna get into this error, right? So there are ways through which we can easily fix this. So there is another way of writing a test. So what I'm gonna do here is I'm gonna create another file and I'm gonna say task sequential. Okay, so what I'm gonna do now. Okay, so let me just quickly walk you through what I have done here. So in Locust, we have this class sequential task set. What it does is we can define a sequence, right? And whatever the sequence for every task we have inside this class, which is actually inheriting a sequential task set, in the same sequence is going to be executed by Locust. So Locust is not going to randomly use any task, not even considering a wait. It's just going to start from the get user and keep executing in the same sequence in the same order in which it is defined under this class, right? And then to execute this, the other difference is you have to create another class where you will be using a STP user, which is our basic class. And then here we have a task variable where we have to feed in as a one of the list element of the class which we want to execute, which has all the tasks defined in a proper order, right? So now to run this, what I have to do is, but here, as I mentioned that if I don't provide any file, then Locust looks for locust file.py, but you can override that with this dash f option and you can give which files you want Locust to consider. Okay, so let's come back here. Let's refresh it and run this with 4 user now, and let's see what happens. Keep seeing this user part. 1, 2, 4 users, right? So let's come back here and see if everything looks good. Looks like it's working as expected. We can see all the 4 API endpoints are being here, but it's just 4 users and we have 1.6 requests. And now this is the first time I'm pulling, our web server. Okay. So I'm just seeing here, how is it happening? So you can see on my web server log, everything looks good. Now what I'm going to do, I'm going to stop this one and write a new. So here, what I'm going to do, I'm going to use 20 users. And I want this to be ramp up with 5 users per second. So meaning eventually once we have a 20 users, then it will start sending the report. Okay, and users, 20 users, and now we can see what's happening. Users, create users. Cool. If I come back here, it looks good. Now I can see very interesting thing. I saw one exception. See what it says. Fast API exception, right? This is something which we have to share with devs, right? So we just found one error and we have to report this. Okay, that's one thing. So that's good, right? We haven't done anything and we are able to break the application for some exceptions, right? Okay, so it seems like, if we are going to increase the users, we're going to have some problem with our server, the way it is written, right? So, okay, that's one thing. Let's increase furthermore. What happens if I just make it 50 users? See, keep in mind, when we have a 20 user, we get into one exception, which we need to report to the dev, right? Now let's see. 25 users, 40, and we have now 50 users. Cool. Okay, now we have some failures. So let's see why those are failing. Oh, now we can see one another error. Sorry, too many clients, right? Too many SQL clients. It means that the way database connections are being handled in IAPI server is not very good. So we have two bugs which we have found in our web server, right? So let's stop first. Okay, so let's document these info. When we have 20 users, let's write this down. We can create a new folder. Then we can say bugs, and inside the bugs, we can have a simple text file, bug details, so we can mention okay, scenarios. So what we had done, we used 20 users to execute following inputs in the file orders. The first one is get, second is create user, third one is delete user. Right? So this was the sequence in which we executed the test cases with 20 users, and we get into fast API exception, right? So copy that because we have to share that with client, with the person who is responsible for fixing all those issues. Since I'm the only one who just built this, so probably I have to fix all these things, right? So this is one of the exceptions which we got. Well, this was another scenario, but the only difference was everything was same, but here we have 50 units, right? And in the first one, we were having a fast API. So there are two exception which we found. It means that, whosoever is the responsible developer, they have to fix it, right? So this is how you can actually break the application. And now it's kind of a soak testing or stress testing where we know that even if we have 20 users or 50 users, our application is actually breaking. So developer has to figure out why those exceptions are happening. Since I am the developer for this web server, I can easily handle that. At least the first one I can easily handle that. What's the exception? I can just put in a try except and I can just give some meaningful information why that is happening. For the second case, where we have too many sync lines are opening, it means that I'm just opening a connections continuously for in my web server, which is not the good design pattern. But what I have to do is I should be pooling the database connection rather than just creating the new connection for every user which comes in, and that's the reason it is happening. So probably I can handle that by just pooling the connection where we can have a fixed number of connection within a pool, and that pool, and then whenever it's needed, those connections are being pulled rather than creating a new for every day, right? So that's for the performance. In the same way, you can keep increasing the user. If you want to do a stress testing, you can keep increasing the number of user, and you can see where actually your web server is crashing. You can increase this users by 100 or 200 or 300, depending upon what's the expectation from your web server. And you have to find out this information for each and every API endpoint, because each and every API endpoints in real time not being used in a same manner, right? So frequency of using those API endpoints varies, right? So you have to get all those requirement, from the person who is responsible for that, and accordingly you can design your performance test. Then you can do the stress testing and the soak testing as well, to just see where your system is breaking, right? And for the performance, if you just see this Locust, we have various chart. In chart you can see the request per second, how it is behaving, and the response time, which is more important, and you have to see where the response time is actually getting increased. Here I can see the spike, and you can just check with your server log what's gonna happen, what was happening at this timestamp, and you can relate why this is happening, why we have a sudden increase in the response time, and then all of a sudden it's getting stopped. it's getting declined. So you have to see all these things in a log, and once you just analyze the log, you will get to know why this is happening. And then we have a failures. You can just analyze why the failures are happening. There is 500 server error. You can discuss with your dev. Exceptions, current ratio. You can see the current ratio. Like as I mentioned that since we have used a very specific class of Locust, that's the reason equally every task is being executed, meaning every endpoint is executing with the same ratio. But if you change the weight, the way we have this written our test cases previously, this number is going to be different, right? Download the data. You can get all the data like request, failure, exception, and report. You can just download those reports in CSV format if you want. You can save it wherever you want, and you can just get all the stats. Same thing. Here we have a logs, right? So you have all the information, and same way, right now we have done all these things with UI. If you want, you can just use a headless option when you are running your command, right? So to run this web UI, let me just stop this. All you need is you need number of user. Let's say I want user 4, and then say R is just a ramp up user rate. And then you have to give let's 20 seconds. Time is 20 seconds, like how long you want to run it. And then you have to just give this headless. This should be good. Right. So what this is gonna do is, rather than giving you the web UI, it's actually going to just do the same thing what you were doing in a web UI. But this time using this headless option, you are actually just running everything on your command, right? So in prompt, and here eventually if you want to capture the reports in CSV format, or you want to create a HTML report, all those kind of things you can just do by yourself, right? So if you just read through the documentation, there is an option to just save every information to CSV, what we have seen just on web UI, and you can just create HTML report if you want to, right? So that's pretty much it. And I will just provide you some more link where if you want to understand the nitty-gritty and if you want to learn the Locust in more detail, you can just go through those tutorial series and you can make yourself comfortable with the Locust. And you can see it's very powerful. Just writing with few lines of code, we can break our application very easily, right? So use this as much as you want in real time, and try to bake the application as much as you can, so that in real time or in production, customer is not able to find so many bugs, because that is what our prime responsibility being a QA, that we should uncover as many as bug in non-production environment, rather customer is figuring out those bugs for us, right? So thanks for watching this, and as always, keep learning new things and stay healthy.